Okay, next we have kinetic energy. So the kinetic energy K of a particle equals the amount of work required to accelerate the particle from rest to speed v. It is also equal to the amount of work the particle can do in the process of being brought to rest. Kinetic energy is a scalar that has no direction in space. It is always positive or zero. Its units are the same as the units of work, that is joules or kilogram meter squared per second squared. So we have the the formula for the kinetic energy, that is 1/2 mv squared, mass times the velocity squared. So what we have here, what is the effect of doubling your mass with your kinetic energy? So as you can see in our equation, 1/2 mv squared, so your mass is directly proportional to the kinetic energy. So when we double the mass, therefore, so our kinetic energy, what will happen to the kinetic energy? So 1/2, if we double the mass, 2m v squared. So nahimong mv squared. So as you can see, na double lang atong kinetic energy. So what about if we try to double the velocity? So if we double the velocity, what happens to the kinetic energy? 1/2 m 2v squared. So what will happen? This is now 4v squared. So this is 2. So 2mv squared is your kinetic energy. So from 1/2 mv squared, that is now 2mv squared. So nahimo siyang times 4. So doubling v quadruples your kinetic energy. So again, this is your formula for kinetic energy. So how about kung maghisgot po tag potential energy, since na naman ta naghisgot naman tawag energy. So potential energy po class, that is due to the elevation, potential energy has the formula mass times gravitational acceleration then times the height. Again, mass times gravitational acceleration times the height. That is your potential energy formula, still in joules. Work energy theorem. When forces act on a particle while it undergoes a displacement, the particle's kinetic energy changes by an amount equal to the total work done on the particles by all the forces. There's a relationship called the work energy theorem is valid whether the forces are constant or varying and whether the particle moves along a straight or curved path. It is applicable only to bodies that can be treated as a particle. So, kining work energy theorem. So, we have here the statement of work energy theorem. The work done by the net force on a particle, it equals the change in the particle's kinetic energy. So the total work is equal to the change in the particle's kinetic energy, or delta kinetic energy. In equation form, that is total work is equal to delta K, or that is K2 minus K1. Total work is delta K, or that is K2 minus K1, or that is 1/2 mv2 squared minus 1/2 mv1 squared. Initial velocity squared. This one is the final velocity squared. Okay. We have here an example. Let's take a look again at the sled in the previous example and the numbers at the end of that sample problem. Suppose the initial speed v1 is, your v1 though is 2 meters per second. What is the speed of the sled after it moves 20 meters? So S is 20 meters. So what is kuno your V2? What is the speed V2? So ang gimian-anan niya nga problem class is the sled problem, this one. wherein the total work na nato obtain nato is 10 kilojoules. Okay? Total work nato for that problem is 10 kilojoules. So the total work is 10 kilojoules. So if we try to obtain the V2, so from the formula sa total work, that is delta K, right? Delta K, kinetic energy, or that is K2 minus K1. Since gitagaan man ta sa V1, selby, masolve na to ang kinetic energy at point 1. That is 1/2 m V1 squared. So that is 1/2 our mass. Since the total weight is given, so makuha na to ang mass by the formula weight is equal to mass times gravitational acceleration. So mass therefore is the total weight over the gravitational acceleration. So that is 14,700 newtons. This is given in the previous problem, divided by 9.8 meters per second squared. You have the mass is 1,500 kilograms. So mass is 1,500 kilograms. Then velocity na to is given to be 2.0 meters per second squared. So kinetic energy for point 1 is 3,000 joules. So we have 3,000 joules. Okay, we have this. Now to get the K2, so from this formula, therefore your K2 therefore is total work plus K1, no? Kinetic energy at point 1. So that is pilaton total work 10,000 joules plus 3,000 joules sa K1. You have now your K2, that is 13,000 joules. Okay, so that you can now solve for the V2 from formula K2, kinetic energy formula 1/2 mv2 squared, so that you can have your V2, that is 2 K2 over m or V2 therefore is the square root of 2 times K2, which is 13,000 joules, over your mass, which is 1,500 kilograms. So that you get your V2, that is 4.16. So this is what is required in the problem. What is the final velocity? Okay. Now, since we are given the displacement, we can also make use of another formula, use another solution using the equations of motion along a straight line. I guess I have you researched about that. So let us try to solve the problem using an alternative formula. We have from Newton's second law of motion, F is equal to ma. You can get the acceleration with this formula, F over m. Now the force for this one is kung tanaw na to class, we have the forces that is nga consider na to. We only have two, since the weight is wala man siya force that is parallel to the displacement also with the normal force. So we only have the tension. So the component of tension along the direction of your acceleration, which is along x. So ang tension na to is going to the right. Ang component niya is going to the right. And also, the friction force, which is going to the left. So, kaya to the left man, ang friction force is negative 3.5. Okay. So, we have positive component of the tension. So, that is 5,000 cosine 36.9 minus the negative friction force 3.5 over the mass, which is nasolve na to ang mass 1,500 kilograms. So, our acceleration is 0.33 meters per second squared. So, now the acceleration, masolve na to ang V2 using the formula for motion along a straight line. V2 squared is equal to V1 squared plus 2AS. So, I hope you have encountered this when I ask you to research motions along the straight line. So, V1, given ang V1, 2 meters per second squared plus 2 times acceleration 0.33 meters per second squared. And then your displacement is 20 meters. So, your V2, therefore, that is V2 squared, 17.3 meters squared per second squared. So, square root of that to get your V2, 4.16 meters per second. So, you get the same answer, class. So, ani, nag-agita sa work, kuha na to ang, given man ang total work sa atong previous, no? Since umpara man siya ang problem. Ikuha na to ang K2, then gi-minus si, from this formula, gi-minus na to si K1 from your total work to get your K2. Then, when you obtained now your K2 from the formula sa K2, that is 1/2 mv2 squared, you now solve for the V2. Dire, nag-agita sa Newton's second law, which is F is equal to ma, and then nakuha na itong acceleration. We apply the acceleration to the formula sa motion along the straight line, which is V2 squared is equal to V1 squared plus 2AS. You get now your V2. Okay, next we have last the power. Power is the time rate of doing work. So, kani silang tulo, class, work, energy, and power, they are all scalar quantity. Work, energy, and power. And so, the average power is the amount of work done in time t divided by the time delta t divided by the time. The instantaneous power is the limit of the average power as delta t goes to 0. When a force F acts on a particle moving with velocity v, the instantaneous power, or the rate at which the force does work, is the scalar product of F and v. Like work and kinetic energy, power is scalar quantity. So, ano sa man dyan kalahian? Since we have here the three, work, energy, and power. So, ang work, by the simple definition nila, work is the dot product of force and the displacement. Power is a time rate of doing work, and then energy is the capacity of doing work. So, sa to, work is the dot product of force and the displacement. Power is the time rate of doing work, while energy is the capacity of doing work. So, maingon kan kag time rate since nagisgot tag power. Time rate, so meaning to say that is per unit time. So, power is work, the time rate of doing work. So, work per unit time. The time rate of doing work. So, delta T. So, muna siya ang power. The time rate of doing work. So that your power is in joules per second. So, the unit joule per second, that is the unit watt. Joule per second. Or 1,000 watts is 1 kilowatts. We also have these different units. In English, we have the unit horsepower. Tingali nakadungog na mo ani nga unit. 1 horsepower, HP. So 1 horsepower is equivalent, that one is 550. Sa English, that is foot-pound force per second. Or that is 33,000. We have 33,000. Foot-pound force. We have also the unit conversion for horsepower to watts. That is 746. So I hope you remember this one. 0.746 kilowatts. Okay, what about the unit kilowatt hour? Have you heard of the unit kilowatt hour? So tingali makadungog mo ana sa inyong electric bills, no? Pila ka kilowatt hour inyohan na consume. That is not the unit of power, but it is a unit of electrical energy, ha? Kanang unit nga kilowatt hour. So that is the unit of electrical energy class. Energy. So that is 10 to the power 3 joules per second. That kilowatt is joules. That is kilojoules per second. So 10 to the power 3 joules per second. Then times 3,600 second in 1. That is 1 hour. So therefore, this is, kung ato na siya ipang cancel, 3.6 times 10 to the power 6 joules, or that is 3.6 times 10 to the power 6 is megajoules. Okay? Okay, so let us answer these problems. Oh, ito sa din yung basahon. So we have the formula for average power work per unit time. This is for the average power. This one is for the instantaneous power. Ang ato ang delta T limits atong delta T approaches to 0. And then another formula, we have the dot product, so meaning to say that that is a scalar product of the force and the velocity. Okay. So time 0, time 5 seconds work you do on the box to lift it in 5 seconds is 100 joules. So power output is, so power is work over time. So work is 100 joules over time is 5 seconds. So mao ni imong power. Work over time. 100 joules divided by time in 5 seconds, so 20 watts. So that is an example. Another example, each of the 2 jet engines in a Boeing 767 airliner develops a thrust of 197,000 newtons when the airplane is flying at 250 meters per second. What horsepower does each engine develop? So simply get the power. So since we have here 2, pero the same ra sila actually. So we are given the force 197,000 newtons and the velocity, which is 250 meters per second. So from the formula, that is the dot product of force and the velocity, 197 newtons times the velocity 250 meters per second. So power for each 4.925 times 10 to the power 7 Your answer, Newton meters per second. Newton meter is joules per second. That is, joules per second is watts. So, in horsepower man daw. So, convert this one. 746 watts in 1 horsepower. So, power therefore is 66,018.77 horsepower. Okay, that is for both propeller driven and the jet airliner Boeing. Another example, a 50-kilogram marathon runner runs up the stairs to the top of Chicago's 443-meter tall Sears Tower, the tallest building in the United States. To lift herself to the top in 15 minutes, what must be her average power output in watts, in kilowatts, and in horsepower? So, we are given the mass of the marathon runner, 50 kilograms. And then you have the height of the building, 443 meters. And the time should be 15 minutes. So, average power. So, power is work over time, right? And then, kani siya nga work that is due to, due to the elevation, due to gravity. So, work na to, we can get the formula for that. Mass times gravitational acceleration, then times the height. No? That is 50 kilograms times gravity, 9.8 meters per second squared, then times the height ng 443 meters. So, work na to is in 217,707 joules. So, this is our work. Now, ang power, work over time. So, this work, 217,070 joules over the time na 15 minutes. So, we have to convert this one. 1 minute is 60 seconds. Oh. So that, this is joules per second. So, imuhang second is makancel. So, imuhang nakarang unit. Your unit for power should be in watts. 241 joules per second, or watts. 19 watts. Now, and the answer in kilowatts, this is 0.241 kilowatts. If we convert that one in to 241 kilowatts, convert that to horsepower, 0.746 kilowatts in 1 horsepower, that is 0.323 HP, horsepower. So you have your 3 answers now. Okay. Now, or we can also make use of another formula, class. We have the formula for power. F times the velocity, since we are namatay velocity, o mag-solve pa ta. So, our F here is due to, the force na to is due to the weight. So, force due to the weight is mass times gravitational acceleration, and then our velocity is the displacement over time. No? Masolve sad din na to siya. So, we have 50 kilograms times 9.8 meters per second squared, and our velocity height is 443, displacement over time nga 15 minutes. So i-convert pag yun nato siya class. There is 1 minute is 60 seconds, so that you can cancel. Okay, so power for this formula same ra gyapon. Maka-obtain kag answer nga 241.19 watts. So still the same. This one. Okay. So that would be all. Thank you for listening and have a good day, everyone.